Okay, so good day everyone. In the previous video, we have discussed about conjunction. Okay, so the conjunction refers to the logical connective and wherein the two statements P and Q will only be true if both of the statements P and Q are true and false otherwise. Now, we will move on to another compound proposition, which is disjunction. So in disjunction, we are using the logical connective or, and we are also forming a new proposition from at least two na propositions. Okay, similar to conjunction. Anyway, let us move on. So what is disjunction? So given two statements P and Q, so the disjunction of P and Q is the statement P or Q. So we have two statements P or Q which are being connected with the logical connective or, and this is denoted using the symbolic na form P or Q. Right. So suppose we have two propositions P and Q. The disjunction P or Q will be true if at least one of P and Q is true. Otherwise, P or Q is false. So consider the two statements. Let P be integer 2 is even. Let Q be 4 is less than 3. So the P is the integer 2 is even is true, and 4 is less than 3 is false meanwhile. Okay, so the disjunction of P and Q, namely P or Q, so we are combining these two statements P, Q using the logical connective or is true. Why? Because our definition says that if at least one of P and Q is true, then it will be true. So even if Q is false, but P is true, so P or Q, disjunction P or Q will be true. Okay. Okay, so this is the truth table for disjunction P or Q. As mentioned, we have two variables P or Q. So the P can either be true or false. And the Q, given that the P is true, the Q could either be true or false. And if P is false, the Q could either be true or false. So these are the truth na the possible na combination of truth values. We have true, 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 false, false, true, and false, false. So from the definition of P or Q, or the disjunction, this will be true if at least one from the statements P or Q will be true. And it will only be false if both P and Q are false. So as you can see, if P and Q are both true, then it will be true. So if P is true and Q is false, the P or Q will be true. If P is false and Q is true, the P or Q will be true. And lastly, it is false because P and Q are both false. Okay, so let us have some more examples. So write each of the following statements in symbolic form and determine their truth value. So the first statement is 1 is less than 2, or 2/3 is a rational number. And the second is 3 is a prime number, or 3 is greater than 4. So let us examine it one by one. So the first statement, 1 is less than 2, or 2/3 is a rational number. So we can see that there are two statements. and that are being connected by OR. Okay, so we let P be 1 is less than 2 and Q be 2/3 is a rational number. Okay, so P 1 is less than 2 is, we know that it is true. Okay, 2/3 is a rational number. Yes, it is also true. So the P or Q, we can see that both of our statements P and Q are true. So the disjunction will be true. Okay, the truth value of this statement, compound na statement, is true. Okay, now we have 3 is a prime number or 3 is greater than 4. So we will express it again into a symbolic form P or Q. So let P be 3 is a prime number and Q be 3 is greater than 4. Okay, so since we are using a logical connective OR, we are using this symbol, means we are getting for the disjunction. So now let us determine the truth values of each of these statements. So P, 3 is a prime number, that is true. 3 greater than 4, is 3 greater than 4? Yes, it is. No, it is false. Okay. But since we are using a disjunction, P is true and the Q is false, the P or Q will be true because our requirement only for this to be true is at least one of P or Q to be true. Okay, so we can say that the disjunction of P or Q, disjunction P or Q is true. Now let's move on to another example. So let P and Q be the statements P 1 is an odd integer and Q 1 is less than 2. So P is true because 1 is indeed an odd integer and 1 is also less than 2. So the Q is considered as true. So our task is to write this sentence in terms of P, Q, and logical connectives and find the truth values of the given statements. Okay, so let us convert this one into a symbolic na form. So let P be 1 is an odd na integer. So P is just this one. So, and then or 1 is less than 2. So from this, we know that this is true and 1 is less than 2 is also true. So the truth value of this is true. Okay. Now we have another sentence. 1 is not an odd integer or 1 is less than 2. So we can see that this statement P is just a negation of P. Okay, if P is 1 is an odd integer, but in here we are adding a not na operator, meaning we are negating P. So we will express it as not P. And 1 is less than 2 is just Q. And the OR is we can use the symbol to represent the OR. So we have the not P or Q. So the not P is just the negation of P. So P is T, true. So the not P will be false and Q is just true. Okay, so at least one of these two is true. So meaning our disjunction is also true. Okay, this is false, this is true. So we have T. Now we will have another statement. 1 is not an odd integer or 1 is not less than the 2. Okay, so this is again just a negation of P. So our P is 1 is an odd integer, which is true. And we are adding here a not na operator. So meaning just getting the negation of P. So we represent it as using the symbol not P. And we also see here that Instead of 1 is less than 2, we are expressing it as 1 is not less than 2. So in short, we are just negating Q. Okay, so we express it as not Q, right? And this or can just be represented by this symbol. So not P, or the negation of P, is just false because P is true, its negation is false. And the not Q is also false because the negation Q is true, so not Q will be false. So both of the statements are false. So meaning the disjunction P or Q is also false. Okay.